Hey everyone, my name is Neo Ge. I co-founded IPFSMain back in 2018, and we are the service provider instead of the Filecoin ecosystem. We've been committed to the Filecoin project for almost 3 years now, and it was a historical moment for the Filecoin mainnet launch last week, and I'm really happy to present today. The talk today will be very similar to the miner show and tell I gave last month. I'm going to go through our Filecoin mining solutions, which includes mining architecture and network topology. Then I'm going to talk about our hardware information as well. Let's get started. Over the past 2 years, we have had multiple architecture designs for large-scale Filecoin mining. After thousands of hours of testing, we've decided to use this Filecoin mining architecture. As you can see, when we talk about the architecture, we don't mean the macro architecture. We believe Filecoin mining architecture is the design of a communications network. It includes the physical and logical layout of the network. It also includes the framework of specifications of equipment, services, protocols, and functions of Filecoin mining. In this current mining solution, we are dividing major hardware into 3 different pieces: the storage rigs, seeding rigs, and snarks rigs. And by separating the storage and computational part, this architecture gives us really good scalability and improves the hardware utilization efficiency on a tremendous scale. In this design, we want storage rigs to complete the first step of POST, generate candidates on their own. At the same time, we use seeding rig cluster for seal pre-commit phase 1, aka PC1, PC2, and C1, and snark rig cluster for C2 and window POST. We modify and rewrote part of the code and made some redundancy changes to improve the POST success rate. By doing all that with this mining architecture, we've significantly improved the mining efficiency, especially for P1 and C2. For example, we could manage to finish C2 under 10 minutes at the start of Space Race 1, and we've done some other further improvements recently as well. We believe a robust network architecture should facilitate system-level functionality as well as robustness and scalability, especially in the face of changes in software and hardware components, application functions, and so on. In our network topology, we are using 2 different internet service providers for each WAN to increase the redundancy. The communication core switch uses multi-switches with 10 gig optical ports for stacking, which is connected to Lotus Node and Lotus Miner. And the data core switch uses dual switches with 10 gig optical ports for stacking, which is connected to the Lotus Miner storage, seal worker, and snark cluster. And the space access switch have 4 10 gig optical ports plus 24 gig electrical ports, dual switch stacking, of course. The 10 gig optical ports are connected to data aggregation switches, and the gig electrical ports are connected to storage. And each storage is connected with 2 network cables, respectively, to the 2 switches. And we did the dual network port binding to improve the storage network stability as well. When you are mining Filecoin at large scale, especially like something over hundreds of petabytes, and a well-built operation and maintenance platform is a must to keep everything in order. So next, I would like to highlight our one-stop O&M platform called File Manager here as part of our Filecoin mining solution. The File Manager includes CMDB, CI/CD, monitoring system, and work order system. I'm going to break it down into details with screenshots for each system. The configuration management database, aka CMDB, is an ITIL database used to store information about hardware and software assets. It is useful to break down configuration items into logical layers. And CMDB helps us understand the relationship between the components of our Filecoin mining system and to track their configurations. It can also be used for things like impact analysis, root cause analysis, and change management. So in the file manager, we use it to help us automatically discover the host, get the host hardware information, identify host failures, and identify which cluster that host is working for in real time. And CI/CD means continuous integration, continuous delivery. It bridges the gaps between development and operation activities and teams by enforcing automation in building, testing, and deployment of applications. Our CI/CD module can help us perform fast and accurate deployment whenever there's an update in the Filecoin network. The component monitoring system provides comprehensive monitoring of the health status of the components like Lotus, Miner, Seal, Storage, Snark, WindowPOST. Like this one, Lotus Monitor helps us node synchronization and monitoring the mempool as well, in case our message is being stuck in the mempool. And the Miner Monitor helps us on order status, miner status, order management, like practicing different pricing strategy and sector lifecycle tracking. The Seal Monitor focuses on the working status of Seal workers, like what is the sector ID and what stage that sector is currently in. It is able to identify various errors that occur during the sealing process and deal with faults automatically. It will stop receiving new tasks until the fault is repaired. The storage monitor helps us on the sector storage status. It will find storage failures actively and perform data migration in real time and make the migration history traceable. Snark monitor focuses on the working status of Snark and the resource demand of it. WindowPOST monitor is responsible for WindowPOST working status and history of all miners. And these monitors, as mentioned, are all part of the component monitoring system. After that, we have the host monitoring interface. All the monitoring system can work together to identify and classify faults in hardware, services, and networks, and notify the corresponding staff to deal with them in time. The work order system manages the workflow and can track various operations and maintenance events. All faults identified through the monitoring system can automatically generate work orders and dispatch them to the corresponding person in charge. This is our exception handling system. The system catches all the exceptions through logs and notified O&M personnel to deal with it. If there are any advanced exceptions like synchronization exception, WindowPOST exception, the system will call the corresponding O&M personnel through the phone interface and ask them to deal with the exception. Hardware information, just like I presented in the miner show and tell, I believe designing a good Filecoin mining solution is like building a wooden bucket. No matter how high a bucket is, the capacity of the bucket depends on the shortest plant. And Filecoin mining is different. It's different than any other computational crypto mining like Bitcoin or Ethereum. Filecoin mining is complex, especially when you are mining at a meaningful scale. If you are seeding too fast, for example, or too slow, so that other components have to wait and stay idle, then you are probably wasting the hardware performance. So the key is to find a balance with cost-effective hardware. Is so obvious that cost efficiency is another metric of Filecoin mining solution. And as a Filecoin miner, you just need to find the right hardware instead of the best ones. I made an analogy last month. It's like running an Uber using Lamborghini versus a Honda Civic. The hardware requirements for Filecoin mining are highly related to the computational resources needed to seal a sector and generating regular proof of spacetime for every sealed sector. And these operations are computational expensive. And things like algorithm implementation, sector size would affect the hardware requirements. So let's focus on the current mainnet with 32 gig sector. First, as a storage miner, you will need a CPU with at least 8 cores. Also, the CPU has to support the Intel SHA extension. If you are choosing AMD CPUs, you will need at least a Zen macro architecture or later. And if you're choosing Intel CPUs, you will need, I believe it's Ice Lake processor or later. Secondly, you would need at least 128 gig of RAM. And as indicated in the Filecoin docs, there should be complemented with a 256 gigabyte of swap on a fast NVMe SSD storage medium. And a powerful GPU could significantly speed up the snark computations. The Filecoin team has provided a list of supported GPUs, but if you want to choose to use other GPUs, you can definitely do that. But you have to manually enable them, and remember, please don't mix the AMD GPUs and NVIDIA GPUs together, as it will cause issues with OpenCL. And the disk selection is really important as well. The Filecoin network parameters are over 100 gigabyte and needs to be read and verified during miner start. So you will need at least 1 terabyte of NVMe-based disk space for cache storage. And this disk will be used to store the data during the seeding process to cache Filecoin parameter and to serve as general temporal storage location. And on top of that, you will need additional hard drives for the final storage of sealed sectors and Lotus chain and etc. Please note that the above spec I was talking about are general requirements, assuming all the mining operations are running by the same machine, which is different than our mining solution and requirements showing in the current slide. And like I mentioned earlier, we've managed to separate everything into 3 different parts. Another thing I'd like to highlight is that we are ready for the algorithm upgrade from SDR to NSC. And that's actually one of the reasons why we chose current architecture and hardware designs. They're built for algorithm upgrade. And I believe to make Filecoin a successful project, we need to move most of the parties in the Filecoin ecosystem closer to users. The current storage service provider could only go down to the IDC level. And I believe one of the most important milestone of Filecoin project would be the time that we lower the hardware requirements to a level where everyone could mine at any scale. And as a storage miner, we want that milestone to come sooner than later. It may sound crazy when I say this because we are one of the largest Filecoin miner in the world. Reducing the hardware requirements would lead to more miners and then increase the cost per Filecoin we mine. But the key is to treat Filecoin mining as a long-term thing. To be a successful miner of Filecoin, the Filecoin network needs to be a successful network first. And that's why we are supportive even to most of the miner unfriendly parameters in the Filecoin crypto economic model. it's super exciting to imagine the future of distributed web. I believe Filecoin would become a big part of it, where we could, or where we will see lots of storage miners, retrieval miners, and repair miners. Hardware requirements won't be a barrier anymore. With repair miners' help, people could probably mine Filecoin on whatever hardware they desire and whenever they want, with flexible time framing instead of 24/7. People could easily transfer petabytes of data with extremely cheap bandwidth. I think this is the end of my talk. Thank you so much for watching. I think I'm 2 minutes over the time. Sorry about that. Next, I think I'm gonna turn it over to the next speaker from StorageHive.
Yeah, so my talk's going to be, I think I was in Show and Tell Space Race 4. It's going to be a similar kind of information I'm going to cover, but definitely quite a different approach to what Neo just talked about. So on my side, I kind of looked at, as a small miner, solo miner, I do actually have 2 other people in my company as well that's helping out. So we're not quite solo, but certainly on the small side for now. You are quite keen and interested on the Filecoin platform. I want to understand the economics of the platform and how we can scale it up. So really kind of focused on how to build the platform as cost effective as possible, and at the same time maintain reliability. So kind of a lot of people talk that what are they doing and what worked. I actually want to step back a little bit and kind of, as my wording says there, you can kind of learn from my mistakes, scratched out experimentation. So that's kind of thing really key for a lot of people that might be new. I know the project's been around for 3 years, but now, of course, as it's going to get more popular, mainnet has launched. See a lot of the crypto news sites are talking about it. So more and more people are going to come into the platform and want to participate. So hopefully some of the information I will share will help people speed up their process of getting into the platform. It certainly needs to be reiterated for this is not like Bitcoin or Ethereum. You don't just buy a system, plug it into the network, and it's up and running. It's a complex platform. There are software involved. There's hardware, storage, networking, internet. All those things have to work really well together to just work in the first place. And then once you kind of get to that level, then the next level is to be able to actually do it cost effectively. So it's not for the faint of heart to get into this. However, if you do and successful, it's really kind of exciting once you get to that point. So let me kind of jump into it. So what I try to focus on is not on the high end, but kind of on the more on the single person, small end miner. What's kind of like the bare minimum requirement that you, at least for now, I know the systems are changing, things are being optimized. As Neo also mentioned, he's highly recommending that requirements do come down. But at the moment, the requirements are what it is. So as of today, October 20th, 2020, this is kind of like the minimum requirements that you need to get a miner up and running. There are like 3 major steps to the sealing process. There's pre-commit 1, pre-commit 2. Commit 1 is there, but it runs so fast you don't really notice it. Nobody talks about it. And then commit 2. So it's really kind of the 3 major steps are pre-commit 1, pre-commit 2, and commit 2. And so on pre-commit 1, this step for now, and I know there are actually some changes that it's being worked on. It's in test at the moment that will allow to use multiple cores. So that's will be coming down the line pretty soon. But as of right now, it's still at this point in time heavily based on just CPU and no GPU at the moment for PC1 work. And so kind of on the bad side, like I said, you need an Ice Lake or newer Intel CPU if you want to go that route. But yeah, in general, most Intel CPUs don't really work well, especially on the lower end systems. So I recommend that you have an AMD-based CPU, especially Ryzen 3s or Ryzen 5s are really cost effective at the moment to run those, as the multi-threaded option of PC1 is going to become available. Then the Ryzen 7s and Ryzen 9s will probably become more popular for PC1, but for right now, Ryzen 3 and 5 is like really cost effective to get your PC1 rig up and running. But on the chipset side, what I found is not like you have to kind of be careful on the bottom end machines. A lot of them will only support like 32 gigabytes, sometimes only 64 gigabytes. If you do get a motherboard with, there are 2 chipsets. I know the B55 is one, and I think the 450 as well. But the B50 definitely does support 128 gigabytes on the motherboard, because you need at least 64 gigs available for every PC1 process that you want to run. So with having 128 gigabytes available, you will be able to run at least 2 PC1 processes on that one system. Swap space, from what I've learned, is you do actually need a little bit more than what the official documentation says. I've noticed the way the software does the calculation for what's available. You know, there's overhead with, you know, other processes and things that's already running on the machine, and you need to make sure that you have space for that. Plus, then for Filecoin to run. So swap space wise, you do want to make sure you have 160 gigs, 160 gigabytes available swap space. Again, it should be on NVMe storage to make sure it can swap really fast. The space, this is the part where it's doing all the work, and you certainly want to be on SSDs or NVMe for the work that's being done. And kind of, you know, depending on how you're doing your deals and, you know, different steps coming in. I know one process from a 32 gigabyte sector, it will actually grow to about 500 gigabytes of workspace as it's doing its sealing process. And yeah, so you need probably a like bare minimum 1 terabyte. 2 terabyte is certainly more comfortable. But I even seen on some workers, I use 4 terabytes, because depending on, you know, if there are, you know, some tasks that are waiting for deals, or it's kind of waiting for a process, or it has to get transferred to another worker, as all this waiting has happened, it's good if you have extra space so that the system in the meantime can still actually start sealing additional sectors. Networking, I initially started with 1 gig. Don't recommend it. I mean, those 500 gigabyte workspace, when a PC1 gets transferred to a PC2 worker, it's 500 gigabytes that needs to be moved around on the network. And that could take like almost an hour and a half on a 1 gig link. So you certainly want to look at 10 gig. And nowadays, I mean, the prices have come down quite a bit on 10 gig. So it is becoming reasonably affordable. And if you only have a main miner and a few workers, you can probably even just directly cable them. You don't necessarily have to worry about having a switch. Just got to, you know, figure out your routing and stuff so that all the machines can reach each other. And yeah, and on the PC1, there's at the moment no GPU needed. So that's kind of like the PC1 process as kind of the bad side and good side that you want to use. Then PC2 and C2, in my environment, I actually run them on the same set of hardware, because at the moment they do kind of need similar requirements. Both processes do need more threads and reasonable moderate amount of memory and GPU. That's kind of the main driver difference between having different set of hardware for PC1 and different hardware for PC2 and C2. So again, on the bad side, yeah, you don't want to use any CPU that's older than 5 years. Memory, you've got to be over 128 gigabytes or more. Disk, yeah, if you, again, in general, anything while you're sealing data, spinning hard drives, especially if it's just a single hard drive, is not going to get you far very fast. It has to be on SSDs. Maybe one comment also on SSDs and NVMEs. You got to be careful with like really low-end consumer level SSDs, NVMEs. On one of my workers, I did kind of go really low end, and like shortly after space race, that node did actually die because the NVMe like literally got burnt out because it can only take so many writes during its lifespan. So yeah, you do need SSDs, and you are going to need you know, higher level, like enterprise level SSDs that can maintain and handle quite a lot of writes and rewrites on the disk. GPU wise as well, you want to make sure if you are going to go a little bit lower end GPU, it should have at least 6 gigabytes or more memory per processor on the GPU card, because the Filecoin process allocates around 4.5. I don't know why it's 4.5, weird number, but it does allocate like 4.5 gigabytes of memory on the screen card. So do get a card with at least 6 gigabytes allocated on it. Actually, but I've seen sometimes it does, you do get some errors on it sometimes still in the allocation. So it is still better to have like a 1080i or something that has at least, I think it has 10 gigabytes of memory on that card. So that's kind of like the sweet spot on the entry level card would be the 1080i. In general, on the awesome side, you do need more threads to do the work of PC2 and C2. So a Ryzen 5 or 7 or 9s work really well for these in general. Again, swap space, it's got to be a little bit higher than the memory that you have on the system. Then yeah, lastly, so on the post, just kind of for people starting out scratch, I've seen like over and over and over on the message boards, this is kind of like the main thing that they trip over. Once they got the PC1 and PC2 working, that's not too hard to kind of get accomplished. But probably the most difficult thing is to get your the window posts to complete successfully in a time frame. And there is it's these Lotus Miner proving deadlines command that you run. It has 48 sections, so it's basically a 24-hour window, 30-minute sections, where every 30 minutes it does prove some of the work that's already been sealed. And the challenge that it sends, you need to be able to do all the work, retrieve the data, do the hash calculation, and send the results, put it on the message pool, and send it back to the chain. And all of that needs to happen in 30 minutes. And if you don't have adequate hardware, that's why you're going to have, so when you see faulty sectors or you lost all your power on the network, it's usually because your posts are just not completing in time. I initially did start with a Ryzen 5 as my main kind of system doing the post, and it was just not fast enough. I did upgrade to the AMD Threadripper, which works really awesome. But I would say now that I've learned a little bit more, it's probably overkill. So you can probably get away with, if you have a dedicated machine for the post, a Ryzen 9 should do the job as well. And again, a good GPU, so at least a 1080i or better, and the memory and the space requirements, that should certainly be able to get you through your post. And just a kind of quick reference, I mean, this is kind of how I monitor my environment. Got a whole bunch of party stations up and running, and seeing what all the systems are doing. It's quite feeling good to see that everything is actually working and sealing some data.